are 5 billion people talking 4 hours a day, and maybe they talk at 100 words a minute. That's about the rate that I'm speaking now. And that's about 6,000 words an hour. And if you do the math, that's 120 trillion words every day spoken in the presence of a cell phone. Now, you could compare that to the things we know about. So one thing to compare it to is the size of the web. Google indexes, oh gosh, I don't know, it depends on when you look, maybe 50 billion web pages. If the average web page has 1,000 words, I don't know if that's true, but probably give or take. Cell phones are twice the size of Google every day. Okay. All the world's words are spoken in the presence of cell phones, and none of the world's words are written in newspapers. Do a first approximation. Right? If you round it off to whole percentages, 0% of the world's words that are produced every day are produced in newspapers. But what do we study? Not just in FIRE, but in TREC, in NTCIR, in CLAY. We almost completely study newspapers. Not completely, but almost completely. So I want to think about what would we do if we weren't studying newspapers. It's useful when you think about a new problem to start with what you know. So here are some things that we know. We know that we're interested in information that is found in documents, right? That is what our community is based on. We know that it is not a problem to recognize what we're looking for. It is a problem to have the machine find things that we will recognize once they have been found. And we know that users prefer short queries, right? So we can start with these as first principles, those ways of thinking about what would we do if we thought more broadly than newspapers. Now, the dangerous thing is not what you don't know. What you don't know, you can learn. This is our profession, right? We're trained to learn things that we don't yet know. The dangerous thing is the things you know that aren't true. And I'll claim that all three of these things aren't true when you start thinking about conversational interactions as being the target of search. So almost all the world's words are in conversations. It is dangerous to start with these as the way of thinking. So let me start out with this question of whether information is found in documents. So this is a project that we were working on, and we get the audio to work.
Small town of about 32,000 population, and maybe a third was Jewish.
You said you were not religious, but you were somehow involved in some Jewish affairs. I understand you were a member of the Maccabi.
Well, after the Hungarians took over. Before that, I belonged to an organization called Sokol, which was also an athletic Czech organization. And of course, when that disappeared after Hitler donated.
So this is an interview with a survivor of the Holocaust in Europe, a Jewish woman, who is telling a story about her childhood, and then she'll tell a story about her experiences in the war. Because she can tell the story, she survived the war, and she'll tell her story about what happened after the war. We did a project, this is many years ago now, predates even FIRE, but we did a project in which we worked with 52,000 people who told their stories. They spoke for 116,000 hours. They spoke in 32 different languages. And our goal was to improve the processing of speech for the purpose of search. Along the way, we discovered that the problem is not quite just that. So this is our first result, which shows you that initially, using ordinary systems, we would get almost every word wrong. And eventually, near the end of the project, we could get 3 words right out of every 4. Now, if you go through a newspaper collection and you remove 1 word out of every 4, your information retrieval performance will not be harmed at all. There's quite a lot of redundancy in news stories, and so things that are said one way, even if you remove the only occurrence of that word, are said another way using expansion techniques, you can pick these things up. So there's almost perfect performance if you have that level of recognition accuracy in news stories. And this is, in fact, already well studied in spoken news stories. This does not work in interviews with Holocaust survivors. So here is what happens when you have a system. This is mean average precision over here. I'll come back to this segment issue in a moment. You have a system that you tune. You get relatively low mean average precision. That's accented speech. It's highly technical terminology. But if you build a system directly for this task, it's called the domain adapted system. This system, this is title queries. This is title plus description. These are in the same form as direct queries because that's what you do when you start, right? Everything looks like the thing before it, so this looked like direct to us when we started. The domain adapted system cost $1 million, US dollars. Because you had to transcribe the data, you had to get a research team together to build the system. We later built the system in the Czech Republic for $100,000, but there are very few collections of these oral history interviews that you can afford to build a system and then run it if it costs you $100,000 just to build the system. Right? So we want a cheaper system. Well, this red system is a cheaper system. I showed you before, you do very badly, you can go down to the corner store and buy this system, but it doesn't do well at all. Now, this is on 38 topics out of 100. So this is a 3-year evaluation at Clay. We did 100 different topics. 38 of them contained a word the speech recognizer couldn't recognize. Now realize, 1 in 4 words can't be recognized, but they're the query terms. Why? Because people who build speech recognition systems, they want to recognize as many of the words as they can. Why is that? Because their evaluation measure is the word error rate. If they get the word the wrong, they get a lot of words wrong. If they get the word anti-disestablishmentarianism wrong, or soccer, then they only miss 1 word, because it's only said once. So they tune the system to get the common words right. Now you said that the focus is information access, not information retrieval. So in information access, we have a user, a live user. So what words is the user trying to use? The ones the system doesn't know, because the user wants to provide very specific terms. Right? So the system builder is trying to build words the user doesn't want to use, and the user is trying to find words the system doesn't know. Right? And that's natural in speech. And so we have to do something about it. So this is the PhD dissertation work of Scott Olson. And what he did was he built a system, as many people are doing, that would recognize unknown query terms by sounding them out. Now this is just in English, but he was able then to combine that with the output of this commodity system to get mean average precision that was, in this case, for title queries, more than halfway to the best that could be done with a customized system. This is the $10,000 solution. This should be a natural application here. we should think about spoken content. Spoken content can greatly expand the range of people who can use this. How many people are connected to the internet today? Maybe 1 billion, maybe 2, yeah? Yeah. How many people have cell phones? 5 billion, you got it, right? Okay, so we can dramatically improve access if we can process speech, and we can process speech using expensive techniques or inexpensive techniques, and we can drive the technology in the direction of the inexpensive techniques if we have challenge problems that require us to do it. We actually knew we were going to do that research when we started. But you remember I told you about the segment mean average precision? These interviews are 2 hours and 15 minutes long on average. That means some are only 30 minutes, but some are 5 hours. So for these interviews, we have to break them up. So they were broken up for us, not by us, but by people who wanted to index this. People who were building a professionally, manually indexed version of the collection. They found the beginning and the end of a unit that you would want to retrieve, and they added some labels that we used when we did relevance judgments, but that we didn't use in the experiments I just showed you. Those units were in the mode, which is the most common segment duration, which is what's shown down here in seconds, about 240 seconds. These are all things at the end where people are holding up photographs and saying, here's a picture of my mother, here's where I live. But these are the ones we're interested in, the ones that are content-bearing in the audio channel. And the mode of the distribution is 4 minutes. Now that makes sense, right? You have to have enough time to understand what they're talking about, and not so much time that they're talking about other things. It makes perfect sense that it should come out to be somewhere around 4 minutes. When we repeated this experiment in Czech, we did not have the benefit of this very careful segmentation. This segmentation was only done on a very small part of the collection, only 4,000 interviews, which totaled about 10,000 hours. It costs $4 million. And because that wasn't scalable, they instead went to a different way of indexing that didn't involve segmentation. So for Czech, we had to have relevance judges not just tell us whether the system was finding the right thing, but telling us where that thing began and ended. We told the relevance judge the question, and we asked them to mark the beginning and end of that which should be retrieved. And the next graph I'll show you is the average length, this is the mean, not the mode, of the segment marked by the annotators. And you'll remember before, the mode of the distribution had been 240 seconds, which would be right along here. Now these are all the different topics, and these people are grouped, these topics are grouped by annotators. So here's an annotator, here's another annotator. This was done in the Czech Republic at Charles University, the work of Pavel Plesina. And you can see that the average, if you ignore the one annotator who either wasn't paying attention or was having a little wine while they were doing it, it comes out to somewhere between 1 and 2 minutes. If I don't tell you the question, you think a natural unit of retrieval is 4 minutes. Okay. If I do tell you the question, you think a natural unit of retrieval is 1 or 2 minutes in Czech. Well, we don't have a direct comparison. Maybe the people in Czech are more concise than the people in English. The Czech interviews were indeed a little bit shorter, mostly because the people in the Czech Republic didn't wish to talk so much about what happened after the war. But probably there is some real effect going on here. So there's no such thing as a document. The question defines the scope of the answer. Now, of course, we already know this, because in our community we work on question answering. And there, the question defines the scope of the answer. But we don't think about it. Most of the information in the world has no natural unit of retrieval. The question defines the unit of retrieval. So there's something worth thinking about, something worth changing our thinking. We see this everywhere. The first time you work on searching email, you will undoubtedly try to search email messages. And then you will find an email message that says, fine, let's do it. Huh? I think that's going to work. Somebody's going to have to tell me, let's do what? So it's not just that our retrieval units start out too big and we have to make them smaller. Our retrieval units start out too small and we have to make them bigger. A friend of mine, with whom I organized a track at Trek on e-discovery, spends most of his time releasing messages that have been asked for by the American public from the National Archives. Elena Kagan worked for the Clinton administration and later was nominated by President Obama to become a Justice of the Supreme Court, our highest court. So everyone wanted to see the email that she was sending when she was working for the Clinton administration, to try to get a sense for how she thinks and how she acts when no one is looking. Okay? So here's an email that is from Elena Kagan to Ian Van Praagh. And I probably won't be able to make the meeting, although I'll try, thanks. Conversation. But you know, the people who work on speech, they're very difficult to work with. You can have a project with them and you'll say, well, how shall we divide up the money? And they say, well, how about we take 95% of the money and you can have 5% because the information retrieval problem is so much simpler. So there is some argument for us to study conversational text in email or in chat or in SMS or you could thread together Twitter or thread together blogs and their comments and mentions of blogs in other blogs. And you could learn quite a lot about how to handle conversations that when our speech brethren get their act together, we could then use. We don't have to wait and build things around expensive speech systems. Okay, so I have a few other things we can talk through as examples if you have questions, but to keep it moving along, let me talk about the second thing that we know that just isn't true, which is this idea that I mentioned in that email that we can recognize what we're looking for. This is the work of one of my PhD students, Amr El-Said, and we started working on email, and we knew when we were working on email what the problem would be. The people in email, they don't write in a formal way. There'd be lots of misspellings, typographical errors, abbreviations. And that turns out not to be true. Because your professional reputation depends on what your emails look like. So people are very careful in the way they write emails. Now that might be true of Twitter or SMS, but email is actually a rather formal medium. So we stumbled across a study in which someone had plotted literature on one side and people talking on the other side and trying to figure out how formal things were. And email comes out very strongly on the formal side of this. So the first direction we thought turned out not to be the interesting idea. But this idea turned out to be fascinating. And so the question here, if you read this email, this is about a conference call, another kind of a meeting, right? And the question is, did Sheila want Scott to participate in this GE conference call? Had to be rescheduled, presumably from some time to some other time. Looks like the call will be too late for all kinds of hints here, but we just picked one problem to work on, which is the question of who is Sheila? If we can answer that question, we can probably answer the question, who is Scott? And if we can answer that question, we might later think of ways of answering the question, what is the GE conference call? And if we could do all of these things, maybe we could actually do what we said we were going to do, which was find you a useful document, not just find you a document, but find you a useful document, right? One you can understand. So I started calling this project Who Dat? Right? And Tomer hates that, right? Because it sounds very informal. Who is that? Who Dat? Right? But Tomer picked this example with Sheila, and I didn't realize it until I went to Australia. Anybody here from Australia? Anybody visited Australia? So a Sheila is a term for a woman, not the most complimentary term. And so Tomer didn't know this, but the talk is now called Who Dat Sheila? Right? Which doesn't go over quite so well as you might hope. Okay, anyhow, Who Dat Sheila? Well, it turns out that there are 55 Sheilas in this collection. Okay? And how do we know that? Well, what we do, this is the Enron collection. Oops, do I have? Yeah, so I don't have the details of how we do it. So what we do is we go through and we find every email that is from someone that gets signed Sheila. And we say, well, there's a Sheila, that email address. And our goal is to tag the reference to Sheila with the email address, so we first find out which email addresses call themselves Sheila. Which email addresses call themselves Sheila in the name? Which email addresses have Sheila in the name or in the email address? Which email addresses receive email that says, hey, Sheila. Originally, our system thought her name was Hey, but we figured that one out after a while because we're IR people and we could do stop words, right? So anyway, we build this list, and then it's a really simple problem to just reverse it. So if I know who can be called Sheila, well, I want to know which of those people this is, and I have all kinds of evidence. Because I know in the messages here, we're talking about the GE conference call. We're talking about this time. We're talking from this person. We're talking to that person. We are drowning in evidence for solving this problem. And so Tomer built a system that could resolve the identity of Sheila. Now, there are 55 Sheilas, but on average, we have 600 different names, and on average, there are 100 and some odd, 106 different people, different email addresses that could be associated with a reference. If it's a reference to the name John, there are 1,412. Right? So, for 20% of them, they're references to people who have no email address. They're like things like, God damn, there goes George again, referring to George Bush invading yet another country, right? So, well, George Bush doesn't have an email address in the collection, but he gets referred to as a person. But this is only 20% of the references. If I take the rest of the references, 80% of them, 64% of the total references are to people who work at Enron, the company that provided the email collection, not voluntarily. And if we just use social evidence, no topical similarity, just social evidence, no thread relations, not even occurrence of the name Sheila in the same message. We just use social evidence. If you work at Enron, we get it right more than 75% of the time. One best, right? So this is a mean reciprocal measure. You get full credit if you get it right. You get half credit if you get it in position 2. You get a third credit in position 3. We'll see this measure again later, right? Above 75%, we can combine evidence from many sources and do a little bit better, but only a little bit better. Now, we got a test collection for this from our friends who work on machine learning. I don't want to say bad things about machine learning people. They're very good people to know. But they start out with the question, how well does my machine learning algorithm work? And we asked them, when you built a test collection for this, why didn't you pick anyone outside Enron as a test subject? And they said, well, there aren't very many emails from those people. Our machine learning system wouldn't have anything to learn from. So this is the difference between a machine learning person and an IR person, right? A machine learning person starts by assuming there's data and asks, what questions can I answer with this data? An IR person starts by assuming there's a problem that we want to solve and asks, what's the best way I can solve the problem? If that happens to be machine learning, that's fine, right? And so we used their collection to do training, and then we built a new collection that had Enron people, non-Enron people, and people who had no email address in the collection that we could find. And when we studied how well our system worked on non-Enron people, we found out that our machine learning friends had been correct. That's the harder problem. But it's also a 100-way ambiguous problem, because we're not starting out told whether this person works at Enron or not, and that problem we can do half the time. Right. Now, that's 100-way ambiguous, and we're right half the time. And the improvement from 50% to 60% comes from combination of evidence. We get very little out of combination of evidence when we're drowning in evidence if you work at Enron. We get a lot out of combination of evidence otherwise. So what's the message here? It is the case that if I find you a document, I'm not done. As you said, this is cross-language information access. This is monolingual information access. And here, I have to translate from Enron speak to searcher speak. Recently, there were some emails released by our former governor of Alaska, Sarah Palin. You can see Russia from her house, I'm told. And those emails were helpfully released on paper. So someplace we have to bring those into OCR and do with the help of the people who run the RISOT test, which is the most sophisticated OCR evaluation in IR any place in the world. And then look at them this way as email. So we're naturally poised here at FIRE to work on questions like this, and there might be questions like this that arise in the Indian context as well, government accountability or whatever. By the way, you said that Google was a gold sponsor, and that the government of India was a sponsor. So I don't know. I'd watch out for getting into government accountability too early. Okay, so what do we need to do next? Well, now that we've done WHODAP, the obvious thing to do next is WhatStat. The problem is, for WhatStat, we can't label it with an email address. We're not given an inventory of all the stats. Right? So we have to somehow generate them. So this is a clustering problem, right? This isn't a classification problem, as WHODAP was. And how would you know if you had found things that were related? That's how we're going to have to show you what that is, right? We'll show you the cluster of related things. But how would you know if you had done that well? Well, if you're an information retrieval person, you'd say, if I could retrieve it better after I knew of related things, then I would have demonstrated that I had learned something. So perhaps we could do a blind relevance feedback experiment, where you build a WhatStat system that finds related things, and if you bring in useful words, I'll believe you found related things. It's a little bit indirect, but until we start thinking about that and try it out, we won't quite know what to do.